think it did. I think we've already solved for this one. So I'm gonna move on. Okay, 1, 2. Few problems left, but we're getting close. All right. This next problem says, as we exercise, our bodies metabolize glucose, C6H12O6, with oxygen, converting it to CO2 and water to supply the energy necessary for physical activity. Write a balanced equation for the metabolism of glucose. So if you don't understand what it means when it says metabolism of glucose, it's just glucose is reacting with oxygen. Okay, so we'll write glucose reacting with oxygen is going to form CO2 and water. So this is a combustion reaction because we're forming CO2 and water. So here we'll write C6H12O6, and we will react it with oxygen, which is a diatomic molecule, so O2. And it's going to form CO2. The problem tells us CO2 and water. Now we need to balance this. So we need 6 carbons on the product side. We need 12 hydrogens, so if I put a 6 here, that gives us 12. We have 8 oxygens on the reactant side. We'll come back to that in a minute. How many oxygens do we have on the product side? 6 times 2 is 12, plus 6 more, that's 18. Well, we already have 6 over here. We need 18 total. So if we've already got 6, we need 12 more. So if I put a 6 right here, that'll give us 12 more. So now the equation is balanced. The next question says, each mole of glucose produces 678 kcals of energy. What is the sign of delta H for this equation? Key word here is produces. If each mole of glucose, when it's metabolized, produces energy, that means heat or energy is a product if it's produced. So if heat or energy is a product, delta H is negative. This is an exothermic reaction. Okay. Next, it says an individual jogging at 5 miles per hour for 30 minutes would burn 272 kilocalories. How many moles of glucose would need to be metabolized to generate this amount of energy in the body? It says this amount of energy. What amount? 272 kcals. So if we look up at the second problem up here, it says each mole produces 678 kcals of energy. We have a relationship there. For every 1 mole of, I'm going to abbreviate capital G for glucose. 1 mole of glucose produces 678 kcal of energy. We just want to know how many moles would it take to produce 272 kcal. So I'm going to start with the number given here in this third problem, 272 kcal. And I'm going to use the relationship I wrote so that kcals cancel. 678 kcal for every 1 mole of glucose. So cross out the units that cancel, kcals cancel, and we're left with moles of glucose. The problem is asking how many moles of glucose would produce 272 kcal. So it should be less than a mole, that's for sure. 272 divided by 678, 0.40 moles of glucose would produce 272 kcals of energy if it was metabolized in the body. In reality, probably less because you have to factor in so many other things when you go in the body, but in a perfect world, it would be 0.4 moles of glucose. Okay, moving on. Last problem. It says an energy bar. Lord, I need an energy bar right now. An energy bar contains 20 grams of glucose. How many energy bars would need to be consumed to generate the same amount of energy in question 3? The same amount. What is the amount of energy in question 3? It was 272 kcals. That was the amount of energy from question 3. So let's read the question one more time. An energy bar contains that 20 grams of glucose. That is a relationship. 1 bar, 20 grams of capital G glucose. Remember, do not forget how to spot these relationships and write them out. This is a conversion problem for sure. How many bars would need to be consumed to generate this amount of energy? Well, we figured out from the problem, there's different ways you can go about it, honestly. What we learned from this third problem up here that we solved for is that 0.4 moles of glucose produces 272 kcals of energy. So I could write a relationship for that. 272, or I'll write it the other way. 0.4 moles of glucose produces 272 kcal of energy. Or we also wrote another relationship between moles of glucose and kcals. It doesn't matter. You could use the one we just wrote out, or you could use for every 1 mole of glucose 678 kcal. Okay? But the reason we need to be able to convert from moles of glucose, kcals to moles of glucose is because right here in this relationship, where we're relating number of bars, energy bars, to grams of glucose, we need to be able to convert to grams of glucose ultimately so that we can convert to energy bars. And the only way we can go to grams of glucose is if we have the molar mass of glucose and we have a relationship that connects energy to moles. So let me zoom in over here. Start with 272 kcals. I've already written it, so we're going to start the problem here. I want to cancel out kcals. So again, it doesn't matter. You can use either relationship that relates kcals to moles of glucose. I'm going to use, in case that was challenging for you to look at the third problem and write out this relationship right here, I'm just going to use this bottom one. We know that 678 kcal is produced from 1 mole of glucose, capital G. Okay, now I need to go from moles of glucose to grams so that I can use this relationship. So how do I go from moles of glucose to grams of glucose? I need molar mass. And if you look that up, 1 mole of glucose is 180, I think it's like 0.156 grams of glucose. So far, kcals cancel out, moles of glucose cancel out. And now we have grams of glucose. Lastly, the problem says how many energy bars would need to be consumed to generate the same amount of energy. So we're going to use this relationship that I marked all over. Where we wrote 1 bar for 20 grams. And we're going to write it so that grams cancel, grams of glucose. So for every 20 grams of glucose, we need to consume 1 bar, 1 energy bar. And grams cancel out, and we will be left with energy bars as our units. So now we just solve for this. 272 divided by 6 678 times 180.156 divided by 20, and you should find that you need to eat 3.6 energy bars. And you know what? Who stops at 0.6 bars? So we'll just say 4 bars. Alright, that is the end of this conversion problem.